Hey everybody, welcome to DOP 310. My name is Andrew Baird. I'm a Principal Solutions Architect with AWS, and I've been here for about 7.5 years now. And I'm here to talk to you today about how to enable decentralized development teams with a shared services platform. It's a topic I've seen a lot of my large customers pursue over my tenure here at AWS, and I'm excited to give you some tips about how I've seen other teams be successful with approaching this type of mindset on the platform. So let's jump in, and I'll give you an agenda for how we're going to get there. First, I'm going to go over a problem statement. It's kind of a similar statement that I see a lot of, especially enterprise customers who are security conscious and very large in terms of the number of development teams they have. This is a problem statement I think that resonates with a lot of those companies that I've worked with. And then we're going to talk about some AWS services specifically that can help in this pursuit of a shared services platform that's helping decentralized dev teams. And then I'll talk about some common patterns for what that platform might look like on top of AWS that you might be implementing. Then we're going to talk about how to crawl, walk, and then run, how to kind of pace yourself and think about the idea that you're having here of how you want to bring benefit to your company. Eventually start implementing and receiving those benefits, and then do it at scale and really have a large impact potentially on your organization. And then we're going to draw some conclusions from the conversations we've had, at that point. But without further ado, let's jump in and start talking a little bit more about specifically how to think about building a shared services platform on top of AWS. So let's start with that problem statement. So this is something that I've heard many times from a lot of different IT leaders, technology leaders from our customers, especially those large ones like I mentioned. That they want to find this balance between the speed of development, delivering new features and functionality for their business and their customers, but balancing that speed against the need to remain secure, to adhere to compliance policies, to make sure they're following operational best practices, that their architecture is designed in a way that allows them to remain available for their customers. So there's this balance they want to achieve. They want to make sure that development teams are working as fast as possible, but not at the expense of cutting corners where possible. But really, when I hear questions like that, the thinking that I have is that there really can't be a balance, right? Especially where those policies that exist, if they're valid policies, especially those that might be related to compliance, they're not really negotiable. Or they shouldn't be negotiable. They're not something that you should cut corners on. They're not something that you should sacrifice for the sake of speed. And I mostly see companies do a good job of thinking that way and remaining pretty firm in the requirements they have when it comes to things like compliance and operational excellence. And because they want to remain firm in those areas, it means that development speed is usually something that can suffer. So if meeting those policies is hard, and you're thinking about how to find that balance, the balance doesn't really exist, and so development speed just becomes slow. It becomes slower than it could be if meeting those policies is difficult. So if you really want to find ways to improve the development speed without having to sacrifice the policies that you've set for good reason, you should be thinking about how to make meeting those policies easier and faster. How can development teams begin to get benefit from and implement adherence to those policies without a lot of complexity that they need to shoulder themselves? And the key here that I want to highlight is the idea of abstractions. So you want to offer the notion of an abstraction to a development team or to your development teams, so that through their use of that abstraction, I'll talk a bit more about what I mean when I say abstraction in a minute. Through their use of that abstraction, they're automatically adhering to policies that might have been more complex otherwise for them to follow. And that makes their lives easier, it makes their progress faster. And then you find you're still not having to make a balance between meeting policies you set and development speed. You've provided faster mechanisms to meet policies that development teams can benefit from. So here's a couple example abstractions that I'm thinking about when I'm making those statements. So the idea of frameworks, the ability to have your developers, while they're building and writing code for their applications, to write smaller, more efficient lines of code that may expand into or be built into more substantial, pieces of software that are, doing things under the covers or have been instrumented to do more complex things that don't require the development team to know more about when they're interacting with just the framework. command line interfaces, which lend themselves really nicely to let development teams build automation against. It can be a really comfortable experience for developers to work with programmatically with programming languages that they're already familiar with. And then finally, deployment services. So taking the application software that's been written by development teams and defining how to take that software and get it running in a real infrastructure environment, and what that infrastructure looks like, how it's been configured, what's surrounding the application. And that's something that the deployment services that you might build can abstract away from the actual act of deploying an application for your development team. So these are some examples of different abstractions that could support DevOps. So for the remainder of the presentation, I'm going to give you an idea about how to build your own CLI, your own framework, your own deployment service from the absolute beginning. You have an idea, you've got your favorite tools and programming languages at your disposal. Let's just start from scratch, go from the beginning, and build your own deployment service framework or CLI using AWS. I am absolutely kidding. Hopefully you did not come to this session expecting, within 45 minutes or so to learn how to build one of those things from scratch in a way that would really benefit, your development organization. So just kidding. The good news here is that AWS has a lot of these things out of the box that you can start leveraging at the beginning of your journey while building a shared services platform. So here's some example abstractions I'm going to highlight. I'm going to dive a little deeper into a few of them that I think are really kind of important and align well to the idea of shared services on AWS. But we have the notion of frameworks, so infrastructure as code, and that ability to distill your infrastructure definitions into declarative code templates is I think a great example of a frameworked approach to how that infrastructure gets created and provisioned. Next, command line interfaces. We have a couple different CLI tools on top of just the typical AWS CLI. That allows you to interact with every AWS service. There's some more abstracted CLIs we've created, like AWS Copilot and the AWS Serverless Application Model CLI, that are more application oriented, that let development teams create their applications directly through much simpler commands and abstracted commands through those interfaces, more than having to create even infrastructure as code templates from scratch. So we have command line interfaces as well. And then finally, different deployment services. So AWS Proton and then AWS Code Deploy, which enable you to interact with some opinionated ideas of what an environment or an application architecture might look like, and the actions or the the mechanisms that exist for how to change that application or get it running within an environment. And through use of either of those two services, allow you to abstract away some of the choices you might otherwise have to make explicitly while configuring the environment or instrumenting your code, so that can be deployed and able to be run within AWS. So there's a couple different services here, I think, that meet a really broad range of application types and architectures that your development teams could take advantage of. And through their use of these abstractions, you can apply some guardrails around them that are shared services oriented, or even build your own abstractions on top of the tools that are offered here, so that your developers are interacting under the covers with one of these services, but they're abstractions that you've built on top. So I'm going to dive just a little bit deeper into three of these services that I think are maybe more crucial or more common for this shared services platform use case than others maybe. So CloudFormation is at its core something that, no matter the direction you take, having a good solid understanding of infrastructure as code and how it's going to apply benefit to scaling adoption in a controllable and programmatic and governed way on top of AWS. Infrastructure as code is absolutely critical. So we're not going to go deeply into the service. If you're not well versed in infrastructure as code concepts or CloudFormation, we've got lots of other sessions this year and in past years to give you all the info you need. But at a high level, I've described it in concept already, but specifically, you'll be taking JSON or YAML templates that declare infrastructure resources that you would like to have provisioned into an AWS account. You take those templates, we're called CloudFormation templates. You upload them to either the console or through the CLI, the AWS CLI, or store them in an Amazon S3 bucket. And then through the use of the service CloudFormation, those templates will be programmatically applied or provisioned into running infrastructure that's been instantiated on top of AWS. So you take that template file. Once that template is applied to the environment, it's called creating a stack. That instantiation of the template that's running in the environment, that's a stack, and that's running infrastructure that's following exactly the configuration options you've selected and all of the different parameters you've provided for how that infrastructure should be built. So you can envision a way where when things are programmatic, they're able to be parameterized and they can be inspected and reviewed like code files can be. If you were to use these as the basis for an abstraction that a shared services team is providing out to development organization teams, you can imagine the ways in which you could constrain or build guardrails or set precedent or define standards, not just through documents, but through actual reusable code mechanisms that can just be picked up and applied to an environment. So you or a team like yours can implement something with complexity once through a CloudFormation template, and then teams can benefit from just picking up that template and reusing it themselves. So that's how that speed gets achieved through CloudFormation. Next, I'm going to talk about AWS Copilot. So AWS Copilot is a purpose-built CLI that lets teams who want to deploy containerized applications on AWS Fargate with Amazon ECS to think more explicitly about architecture and the architecture of their containerized application more than about the underlying infrastructure on AWS that's going to support that architecture. So there's actions and commands that they run that allow them to think about what type of application is this? Is this a web application? Does it have a load balancer? Is it a worker that's interacting with some type of asynchronous process or message queue? They think about the application they're writing and then interact with the Copilot CLI to actually implement that application following the architecture selections they've made without having to make any choices related to the infrastructure that's being created under the covers. And all of that infrastructure is going to automatically follow best practices according to us. It's going to automatically integrate with things like continuous delivery pipelines. It's going to provide visibility and telemetry with operational tools like CloudWatch. So all of those things come out of the box, just simply by interacting with these abstracted CLI commands for running containerized apps. So here's an example of what one of those commands might look like. I'm going to initialize a new application called reInvent demo. I'm going to go through a little handy quick wizard that's describing this as a load balanced web service. I've got a service name here that's called API. I'm pointing to where the Docker file is that defines how my containerized app is going to be built and its dependencies, the different attributes associated with it. And that's all I need to do. And then once I've executed that command and gone through the wizard, AWS Copilot will automatically create a slew of infrastructure, things like the networking environment, the identity access management roles and policies, routing between things like the load balancer and the service. All of those things will happen out of the box. Teams will need to learn those things deeply and overcome that learning curve in order to get started. They just work with the abstraction layer provided through the Copilot CLI, define what their app needs, provide their container image, and they're off and running with infrastructure you can have confidence is going to follow best practices and is also going to follow an architecture pattern that you can review as a shared services team. You can have confidence that infrastructure is going to follow a pretty templated set of characteristics, and you can build around that additional kind of platform level knowledge or telemetry governance, knowing that your teams are interacting with the AWS environment through this opinionated and constrained, abstracted command line interface. Understanding kind of the different layers of Copilot that your development teams would be interacting with. I've got a diagram here on the right that would show a couple example services. Those orange boxes represent ECS tasks that are running. So I've got two different types of applications here. I've got one that's a service and another on the bottom right that's a job. And those things run as deployed container-based applications within the context of an environment. So you can have different environments. You might call them things like dev and QA and production. So different instantiations of the running service is running within an environment, and the deployment to that service or deployment to that job is happening through an automatically configured CI/CD pipeline that's backed by AWS Code Pipeline. And all of those different environment instantiations are running examples of the overall application that you've defined. So for the benefit of brevity and to consolidate this diagram, I've shown two different types of applications that might live here inside this one diagram. One is a service and another is a job. But each one of those would represent its own individual application with all of those other, the rest of the terminology I just walked through. Last but certainly not least, this is a service, AWS Proton, that I think may be the most purpose-built service that we have for teams like yourselves. If you're hoping to create a shared services platform with that type of interaction between platform and development team in mind, Proton is the service purpose-built for those types of use cases. So let's describe a little bit more before I hype it too much about exactly how it works. So again, it's built with platform teams in mind. It brings a lot of best practices out of the box around automating provisioning and deployment. It's going to make sure you're interacting with environments through infrastructure as code, and that's the mechanism that's going to enable governance, establish guardrails, set standards. So through your use of Proton, you're going to automatically enforce the benefits of those things, and while integrating kind of application deployments that your dev teams use with CI/CD, not just for the applications, but also for environments and infrastructure changes as well for the services that you're deploying to. So explicitly with Proton, you can think of it in two different types of users. There's administrators and developers. So you can already tell with the service set up this way that it really has this notion of platform teams in mind. So there's administrators who I assume I'm mostly talking to at this session, who are going to publish templates. They're going to create models for what infrastructure typically looks like for an AWS account, an AWS environment in your organization. You're going to define standard architecture patterns that teams are able to provision into that environment, and you're going to instrument those two things, the environment and the application, with any additional kind of features, functionality that you want to take advantage of on the platform. So things like CI/CD pipelines, observability tools for things like monitoring and tracing, and then your developers are able to come in a self-service way and see the catalog of templates that you've published, the different types of application patterns, the places where the environments are running, and elect to deploy their applications or instantiate versions of their applications that follow your patterns in the environments you've created. So a great division of responsibility for organizations who want to kind of follow this type of model. So let's dive one layer deeper and kind of show you exactly what the interaction model looks like when you're working with Proton resources. So we have infrastructure administrators up on the top left. We've got development teams on the bottom right. And we're going to kind of define the flow of what working with Proton feels like. So you're going to first define environment templates and service templates. So an environment template is going to specify kind of the supporting infrastructure that's existing around the application. So things like a networking environment, IAM policies, maybe standard S3 buckets, maybe VPC endpoints, maybe Lambda functions that provide automation for operational activities or integration to third-party tools that are important for your organization. So things that are going to always exist for all applications and be shared by them in the environment. And then you'll create service templates second. So service templates are the actual definition of what a particular architecture might look like for an application team, for a development team, to deploy or to instantiate into the environment that you've created. So you take that environment template, you create an environment from it. This is a real kind of surrounding set of supporting infrastructure that's running in one or more AWS accounts. You can deploy those environments to. And then once that environment's created, the development teams will come and view all the different service templates you have, customize them to their own application's needs, because you'll have parameterized them with choices they can make. Things like, where is their container image inside of ECR? which S3 bucket have they created or do they want to name for their use of the service. And after they've customized their service template, they instantiate it and run it in the environment that you've created. So again, this really great division of responsibilities that gives you all the governed benefits and structured benefits that infrastructure as code brings, but interacting with infrastructure as code on two different sides of the SDLC. One with a more infrastructure or platform-minded set of responsibilities, and then self-service interaction with those environments to create services and actual running applications inside the environment. So that's Proton. So for the next section, I'm going to take a step back, now that you've got an idea of different services that play a role here, and describe some overall patterns for platforms that I've seen many customers pursue that'll give you a deeper idea of just exactly the type of implementation your team might pursue to help build those abstraction layers that teams are gonna be able to work faster through. So different platform ownership patterns. So first platform I'm going to call out, or design paradigm, is this idea of treating the creation and customization or instrumentation of AWS accounts for your organization as the platform. So you'll build automation and software as a product that you'll run and you'll own as a team that is responsible for creating the AWS accounts, and that the rest of the development organization will eventually deploy their applications to. Services that are relevant here are like Control Tower, CloudFormation, obviously, AWS Organizations, AWS Config and Config Rules. So all of those tools that we have that help enable central security, governance, platform teams really instrument important kind of foundational components into every AWS account that their development organization should have included in their accounts before they add any of their custom applications. So the types of things you might build specifically into those accounts could be VPCs that meet design standards that you require, different security aspects like maybe firewall appliances or routes to things like transit gateway. You can create DNS records. You can set policies with config rules. So all of those types of things you might instrument into an AWS account before a development team is even allowed to have access to it. So that type of implementation is something I would refer to as a platform. You've built a platform that is provisioning, or sometimes we say vending. You're vending AWS accounts that meet the standards your company has set. And by setting those standards and building guardrails into the accounts, you can have more faith that development teams can work more quickly within the standards and policies that the automation and the instrumentation you've built is giving them. The next type of platform that I've seen is really common is for companies and organizations that have a broad pursuit of containerized applications as an architecture pattern. A lot of companies may decide the actual management of those clusters, the platform layer underneath those containerized applications, is something that they might want to centralize. They have a team who is responsible for the provisioning and the care and feeding of those container clusters, and then application teams will deploy their specific applications that are container-based into that infrastructure environment where that container management service is running. And they're only responsible for the application-specific aspects of the code that they've written, and interacting with the mechanisms you've given them to actually deploy those containers into the platform you're operating. So in this type of model, usually we've seen the container cluster and all of the infrastructure underneath it. So that includes AWS accounts, any supporting infrastructure, really is operationally the responsibility of that central platform team who is the real administrators of the environment. And they have built and provided mechanisms to allow teams, development teams, to deploy into that environment and elect to have maybe other AWS resources provisioned into it as well. So things like S3 buckets and DynamoDB tables. They may bring infrastructure as code templates or interact with CI/CD pipelines or command line interfaces that you've built, all with the explicit intent of eventually there being custom code software that represent their applications running in a container cluster that your team, the platform team, is responsible for. So depending on the type of kind of container management service you're using, the architecture patterns that your teams gravitate towards, that'll give you an idea of which services of ours you're able to work with. So services like CloudFormation and the CDK using CI/CD is going to be really, really flexible, because it's going to allow you to adopt the full suite of AWS services and resource types within AWS, and you can give that flexibility to your development teams to interact with your platform through templates. Or if you want to be a little more opinionated, you can elect to have them use something like Copilot, like I described before, where their interaction is going to be purely through a container CLI, and is going to deploy to accounts and clusters that your team is managing on the backside for them once they're up and running. So container clusters as a platform. The last pattern I'm going to highlight is this idea that there isn't actually a running platform, real infrastructure or real platform that your team is operationally responsible for usually, but just this idea that there are templated patterns of applications and architectures that you have defined as allowable or able to be deployed into an AWS account that your development teams come to and choose from in order to bring their source code, their application code to those options and have them deployed through those patterns that you've defined. So those patterns could be defined in a service like Proton, which I described. It could be defined through products available in AWS Service Catalog, which just natively allows you to bring CloudFormation templates directly to it. You could be building constructs within the AWS Cloud Development Kit, the CDK. And you have a choice here where the actual ownership of the AWS account kind of depends on how your organization is structured. If you're the type of organization where development teams are much smaller, more lean, sometimes maybe you depend on third-party vendors to come in and provide development services for applications they're going to build. But really, once they're running, you have a much larger kind of infrastructure operations organization who is responsible for the real running environment where those applications live. You may dictate that those accounts and those infrastructure environments are really owned by that larger centrally operated central operations team. But if you're the type of organization where development teams are more decentralized, and there's far more developers in your organization than there are infrastructure administrators or operators, you'll probably invert that choice, and the AWS accounts will become the owned responsibility of application teams, and you will just provide patterns in some consumable way to those teams, but the operations will be fully those development teams' responsibility once they're up and running. So that's another popular pattern here. So there's not really necessarily a running custom platform, but you've used one of those mechanisms that we've provided to create patterns of infrastructure and architecture and some governance around making sure that those are the choices that your development teams have to live with when they're running their applications. Okay, so you've gotten some thoughts about the services that play a role here. You have a couple ideas of the typical patterns that I've seen be popular among our customers. Now let's talk about, where do you start? How do you go from crawl to walk to run? So for crawling, the first thing you want to do is demonstrate value. You don't want to come in with the mindset of you're going to build it holistically first. You're going to get a platform fully featured, and then once it's fully implemented and ready for zillions of use cases in your org, then you're going to start demonstrating value. You want to have minimal viable product in mind, and you want to demonstrate value quickly. So the way that I recommend you approach that mindset is you find one team. You find one development team that you can partner with. It may even be your own team. If you are a development team who has found this as a broad problem in your organization, maybe you've thought you want to implement a platform that others will eventually benefit from. But you need to find one team. You need to focus on improving their life in terms of making it easier to meet, adhere to policies for future applications or for their existing applications. And then once you've done that and you've implemented a mechanism to do that, you repeat that success. So you want to find a team that has a typical use case. You want to make sure that the interaction model between your team and their team, if it's a different team from yours, is really explicit about where the boundaries are in terms of what mechanisms you're providing to them, how do they interact with those things. It should always be service-oriented rather than kind of human handoff-driven. You should be thinking about infrastructure as code, as a way to kind of encourage those types of handoffs, CI/CD, and then really explicit understanding about what the operations ownership outcomes are. Once you've built something that that this team is going to use to create their application with, what's the support model? Do you take defects on what you've handed them? Are you part of the on-call chain of command if something goes wrong with their application once it's up and running? You've got to be really explicit, together between your teams about exactly what the ownership outcomes are for what you're creating together. So a couple ways that you might choose the right service depending on the use case you're going to explore with that team first. Here's some thoughts to have when approaching which choice of service you're going to make on our platform. So just building a model around interacting with each other through CloudFormation is great because it has lots of flexibility. It's super generic. It's a good choice when your team wants to either own nothing operationally, you just want to provide them templates that help them get started and make their life easier because things have been templated for them, or you want to have ownership of everything where you're going to work on the creation of those templates together, and they'll get deployed into an environment that you have ownership of, but because it's been templated, you can have confidence that it's going to be governed and only deploy what you're willing to have defined within that template. So it's a good choice when you want either one of those extremes of an ownership model. Copilot, obviously great for containerized applications, especially when your development teams, haven't historically or you think would struggle to care about infrastructure deeply. Copilot is a great choice. And then Proton is a great option when you want that explicit division of responsibility that's going to be shared a little bit between infrastructure and application. And you want to blur the line, a little bit more than all or nothing between infrastructure and application. And you want to have opinions about environments of infrastructure, but give flexibility for applications. So Proton is a great choice for that model. I've linked here, and as always with reInvent, these slides will be available afterwards. Some kind of starting points where you can see example applications and sample templates for each one of these services that I've called out. And some ideas of what you'll find there and what you'll review when you come across them. So you've gotten crawling, you've got this first team, you've demonstrated you can improve their lives, you're having success, you've championed, hopefully, I should say that team is willing to be a champion for you because they agree that you've improved their lives. It's important that they agree to that. Now you want to start walking. So in order to start walking, you want to focus on these things. You want to document, you want to market, and you want to scale. You want to treat this platform you've built, this approach you've taken, as if it's a product in your organization. This isn't just a side project. This isn't just something that is something you've built haphazardly. You want to treat it like it's a formal product. Give it a name. Document it thoroughly. You should be able to ensure that developers are able to onboard to whatever you've built without interacting with you as humans. As fun as it is to explain what you've built and show off demos and things like that, you need your documentation to live on its own, so that these teams are able to consume what you've built without interacting with humans. If developers have to raise their hand and interact with a human, that's enough friction to cause a lot of ideas to unravel eventually. So documentation needs to be a suitable replacement for those interactions. Once you've got it documented, only after you've gotten it documented, you need to start marketing what you've built. So take that first team that you've had success with, you get sponsorship through that success with your leadership, you go on a roadshow, you recruit other teams to come see what you've built. Hopefully, because you're making policy adherence easier, your leadership is all for it, your security organization agrees that adopting what you've built is a good idea. And you go through that kind of marketing cycle internally to recruit more teams. And then through that marketing, you're going to need to prove that what you've built is a scalable solution. Hopefully those decisions you made with that first team about kind of explicit operational boundaries and ownership is something that really was going to apply to all the teams in your organization. If every team in your company decided to start utilizing the platform you built, where are those bottlenecks going to be? Is it going to be about onboarding? Is it going to be about how many people you have to operationally support questions or defects or running applications if you're going to actually be responsible for the infrastructure? So you need to prove out that your approach is going to scale. And once you've done these three things, hopefully you've demonstrated that you've built something with real staying power that's really going to benefit the company long term. And if you've done that, that's when you can start running. So rather than kind of show you what a complex example of what one of these shared platforms is going to look like, I'm going to ask that you just more think about the mindset that your organization has when it's evaluating success. What kind of goals do you set? What does your leadership evaluate when they deem something successful? And then create a flywheel around that. So a flywheel, if you're not familiar with the term, it's a really popular term here inside of Amazon, but it's not unique to Amazon. So flywheel is the idea of a virtuous cycle, where every stage of that cycle is going to generate momentum that helps increase the momentum of the next step. So it's this really great positive feedback loop where momentum is forever increasing, and feedback from one stage to the next is really virtuous. So there's example flywheels here that I've kind of shown on the bottom for how you might think about the platform you've built and what success would mean in your organization, and how to make sure that you're always thinking in terms of this flywheel and how the different stages of it should be closed and should reflect in actions being taken, or success being celebrated as each one of those stages concludes. So if you're the type of organization that your goal is to invest in the size of the platform team, the number of people that are building for it, the number of features you're delivering, the amount of code that you've written that is helping meet policy, the number of policies that you're adhering to today compared to yesterday before the platform. You want to create a flywheel that's showing how the introduction of those platform features is benefiting developers through how satisfied they are with your job. You're collecting feedback from them, how satisfied they are with the platform you've built. You're able to demonstrate the number of developers is continuing to scale, the more teams that are coming on board. And you're able to quantify by having more teams adopt your platform, the efficiency of the organization has gotten better because explicitly you've built instrumentation or infrastructure or controls that meet policy guidelines easier, or with less investment for those application teams. So you can think that way. Or you could just think about the scale of impact you're having, the number of teams that you're working with on a daily basis that are leveraging the platform you've built. So by recruiting those new teams, you're continually evaluating the types of requirements they have that might be unique to them that no other team has had to implement before. New programming languages, new architecture patterns, new scale. New performance, all sorts of things that will be unique each time a new team comes to you and wants to adopt the platform you've built. And you'll work with them to expand and extend the platform to meet their requirements. And as you do that, you've now made it easier, not just for that team, but for future teams to come and benefit from. So you want to always think about this idea of a flywheel, right? That's how you get longevity in what you've built. You don't just want to build something for the sake of it being effective and for the sake of it being good. You need that implementation to really be able to measure and demonstrate how it's created a flywheel of benefit for your organization. And that's what will ensure it grows at the scale that you expect. Okay, so let's summarize what we've talked about. We've covered a slew of different services. Hopefully I've inspired you to think about a couple different approaches you might take. There's a lot of options you have in front of you. You're not alone. There's all sorts of teams and companies that have come before you with the same goal in mind that have achieved a lot of great things on AWS with building shared platforms and benefiting their development organizations. So how do we lead from here? Thinking about abstractions. You want to build abstractions that help make hard work easy. You don't just want to make abstractions because it does something cool or creates something cool. But the target of those abstractions is about making things easier, making the life of a developer easier when they work with the abstractions that you've given them. You want to focus. Usually, the hard work will focus on things like policies that are hard and require heavy lift, complex architecture models that could be turned into patterns. You've enabled them to work with those patterns and whatever their preferred interaction model is at the development organization. Is it through code? Is it through command line interfaces? Is it through a console UI that you're going to build for them? And you've ensured that whatever abstractions you've built, the ownership model is aligned to the organization structure that you have as a team and that you're intending to support. So whatever you're building for them and however the applications are going to be running inside of that platform you've created, all the ownership model is aligned to the way that your organization is set up. And then once you have a vision about what you're going to build and how it's going to improve everybody's life on the teams across your company, you're going to treat that vision like it's something that needs to be manifested as a product. You're going to document it. You're going to market it internally. You're going to support it like a product, just like you would for your business's customers. And if you've done all of those things and you're thinking appropriately about the value you're delivering and how it's feeding back into itself through one of those flywheels, I think you'll be really surprised at the amount of scale and impact that even a small number of people can have when they leverage these services and build really cool platforms on top of AWS. So I hope you learned a little bit. I hope you're inspired to think about the things that you might build. Start small, find one team, think really deeply about the problems and complexities they have to deal with, and build an abstraction. Abstract that work away so that they don't have to deal with it. Thank you again for attending my session. My name is Andrew Baird.